Okay, so let's continue from the previous video. All right, so in the previous video, we learned how to actually integrate the trigo function. And if you recall back, all right, so the integral for the trigo function that we learned in the last video, right? Generally, the pattern is very restricted. That means if let's say you integrate cos, you'll get sine. Integrate sine, you get negative cos, and also integrate secant square, you got tangent. And then all the patterns here are only restricted for power 1, like cos power 1 with mx power 1. Okay, sine power 1 with mx also power 1, and then secant square with mx power 1. So other than this basic pattern, right, generally you cannot apply, okay, the rules here. As an example, if let's say you're having cos square, how are you going to integrate it? So actually we will have some other methods to integrate. So for this one we call as basic integration. The three types here we call as basic integration for trigo. And these are the pattern you can only integrate for now. All right, so if you're having some other power like sine power 2, sine square, okay, or some other power like tangent and everything, we will have other methods to do the integration. All right, so we are going to learn it from slowly from video to video. All right, so different patterns of trigo, we have different methods to solve for the integration. Okay, besides the three, these three are the basic one. All right, okay, so let's continue to the next part that we are going to cover today. So here, if you look at the notes, they will say that when your integration for trigo function is not the standard integral, then generally when you want to do the integration, there are many ways. All right, different patterns will have different ways. So from here, for this video, we are going to discover to use the trigonometric identity that we learned before, okay, to change our question into something that we can do the integration. Okay, all right, so this is what we are going to learn it here. So from example 7, 7, 8, 9, and 10, there are 4 patterns of the question, okay, that I will show you later. All right, okay, so let us have a look for example 7 first. So all the example here, right, all the techniques here, how we do the integration, everything. Of course, for now, I can show you the steps, the solution. So it is a suggestion. That means in the future, when you want to solve any integration for trigo, right, you have to try to identify the correct method yourself. Okay, but after you try more, then roughly when you look at the question, you will know that the correct method that you can use. At first, maybe it is a bit tough because when you need some time, okay, to look at the question and then to try to check and see what is the correct method. All right, but after you try a few more times, then you will see the pattern more or less are the same. So then by that time, you will be able, okay, to get the correct method very easily. All right, okay, so let's have a look for example 7. Okay, so for example 7, this method is applicable for cos square, okay, with power 2, with even power. All right, like cos square, sine square, cos power 4, sine power 4. Only for cos square and sine square. All right, and then like cos power 3, cos power 5, sine power 3, sine power 5, all those things will have other methods. So you see that the method is very particular because different power will give you different methods. You need to use different methods. Okay, so again, this example 7, okay, the method can be used is for even power for cos and sine only, not for tangent also. All right, okay. And then for this method that I'm going to show you here, it is applicable for cos and sine even power. And then, and if they didn't suggest you or they didn't give you any hint on any method to solve it. So like this one, they straight away ask you, okay, integrate the fx, that's it. All right, so they didn't give you any hint or any other method to solve it, then you follow the method I show you here. All right, if let's say they give you some other hint or other methods to solve, then you follow the methods that's suggested by the question. Yeah, all right, so let's start. When you're having the cos square or sine square or cos power 4, sine power 4, or the even power for cos and sine, then generally you need to use the double angle formula. Okay, so double angle formula that you learn in chapter 3. Okay, so for chapter 3, for double angle formula, right? We will focus on this one, cos 2x. So for cos 2x, there are three formula here, which is 2 cos square x minus 1. And then another one is 1 minus 2 sine square x. And then another one is cos square x minus sine square x. There are three formulas of cos 2x. All right, so here you will see that why I choose the double angle formula for cos 2x is because of on the right hand side, you will see that you are having cos square x here, you are having sine square x here. All right, so therefore this is a suitable identity for us to use when you're having the even power for cos and also the sine. Okay, so I will ignore the last one, cos square and sine square, because in our question usually we'll focus on one only, either is cos square or either is sine square. Okay, so if you look at the question here, we are having cos square 3x. Therefore, I will also ignore the formula with sine square. So this is the formula that I want to use. Okay, but before you apply it, you need to do some adjustment for the angle, because for this angle, they are having 3x, cos square 3x. Therefore, in this part, I need to change it become cos square 3x also. Okay, if I change it become cos square 3x, then what happened to the original function here? It will become cos 6x. Because I think I told you before, right? For double angle formula, you can adjust the angle, but you cannot adjust the pattern. Right, so I will adjust the angle to 3x because in my question here, I'm having cos square 3x. All right, so that's why I change it. And after that, I will rephrase it into the pattern that I want. So maybe I will change it like this. So 2 cos square 3x be written as cos 6x plus 1. Okay, so now I'm going to use this identity, all right, to substitute into my steps here. Okay, so how can I do it? So I will do something like this. So I want to integrate 4 cos square 3x. Okay, so I can take out the 2 and then I left the 2 inside. So I'm having 2 cos square 3x dx in the question. Okay, so I cannot integrate cos square 3x straight away. Therefore, I have to apply the double angle formula that I write out just now, which will become 2 and then cos 6x plus 1 dx. Okay, so here you will see that, okay, like in the question now, you're having cos power 1 with x power 1. So it is a basic standard integral for trigo. And then value 1, you can also integrate straight away. Right, it is a very basic integration. Therefore, what do you have here is to integrate cos, you will have sine. So sine 6x, copy back the angle, then divided by the differentiation of the angle itself. Differentiate 6x, you get a 6. And then plus, integrate 1, you get a x. And then plus c. All right, so if you rephrase everything, then you're having 1 over 3 sine 6x plus 2x plus c. So some students will ask me, actually for the c here, should I include the 2 inside? And you write it become 2c. Okay, so in my opinion, right, because 2c is still a constant, c is also a constant. So no matter how, I will just write it as a c. All right, if you want to write out 2c, also not wrong. Okay, but if you check the marking scheme and whatsoever, right, they will usually put it as a c only because 2c is also a constant. So it's easier for them to rephrase everything, become a c only. All right, so this is the answer that we get. All right, so from this example, you'll see that if you want to integrate the cos square something or sine square something, then generally we are using the double angle formula if they didn't suggest you any methods, okay, to apply. All right, so if you're interested, of course, you can try sine power 2, sine power 2. Okay, so for cos square and sine square, it looks like very simple. If you're interested, you can actually try to integrate the cos power 4. If you want to integrate cos power 4, right, you have to apply the double angle for 2 times. So the steps will be quite long. Okay? Can? All right. So you can try it out. Maybe for here, I will want you to try it out on your own. Okay, how about if you try this one? Try this yourself. Try this. Okay, so how about if let's say I want you to integrate cos power 4, maybe 2x. Okay, so if you want to integrate cos power 4, then generally what you need to do is like you have to separate it first, cos square 2x, and then it become cos square 2x. So that cos square multiplied with cos square, you get cos power 4. Okay, and then you change, or you can write it something like this. I think better like this. Okay, maybe I can write it as cos power 2 to x power 2. Okay, so again, first, this part you substitute the double angle formula, and then after you continue, right, you will get something like this. Cos power 2 for x plus 2 cos 4x plus 1. Okay, all right. So after you get this one, then you cannot do the integration yet because this part you still have cos power 2. Therefore, you have to apply the double angle formula again. You have to adjust the angle again, okay, and apply the double angle formula again here. So this is the second time you apply the double angle formula. This one is the first time. Then this is the second time. All right, so after you apply the double angle formula, and when you rephrase everything, okay, then only you continue to do the integration. Final answer should be 1 over 64 sine 8x plus 1 over 8 sine 4x, and then plus 3 over 8x plus c. So the steps here will be much more longer. All right, because you have to apply the double angle formula for 2 times. For cos power 4, even for sine power 4, also the same thing. So in our syllabus, right, so far until now, what I can see is that they just ask us to integrate the highest power until power 4 only. I didn't see any power 6. Power 6 even longer, so I don't think that they will ask you to spend time there. All right, but make sure that you try out this cos power 4 answer, the question, and try and see whether you can get an answer here or not. You have to apply the double angle formula for 2 times. Okay. All right, so this example 7 is to show you how we do the integration for cos square, sine square, cos power 4, sine power 4 by using double angle formula if the question itself didn't give you any hint how to do it. Okay, then if we proceed further to the next example. All right, so for other patterns of the integration, like example 8, example 9, example 10, usually in the first part, you will see that they ask you to prove something. Okay, and after that, they ask you to do the integration. So when you're having this kind of question, right, generally, the proving part is actually a hint for you, okay, to do the integration later. So that means in part number 2, you need to use the proving part, the result in part number 1, and apply it. Then you can continue with the integration. So for example, 8, 9, and 10, the pattern is like this. Example 7, they didn't give you any hint, so you have to use double angle formula for the pattern that I showed you just now. All right, so for example 8, you can see that first part they ask you to prove something, and after that only ask you to integrate. So let's start. Okay, so they want you to expand 2 identity here. This one is the first one. Okay, and this is the second one. So they want to expand both. All right, so if you look at this question here, generally what is it? It is actually the compound angle formula. So you can treat the 3x as A, x as B. So you're having cos A minus B. And then the same thing happened here. This one is actually cos A plus B. All right, okay, so maybe you have to expand it first. If you already forget the double angle formula, go back to chapter 3 and have a look again. All right, so all these small details you will see that you use very often here and there. So make sure that all the identity you remember it. Okay, so let's start. For cos A minus B. Okay, so for cos A minus B, if you expand it, you have cos A cos B. Then plus sine A sine B. A is 3x, right? So I'm having 3x here. So sine A sine B. Okay, and after that, if let's say you try to simplify 3x minus x, so 3x minus x, you have 2x. So cos 2x is actually equals to cos 3x cos x plus sine 3x sine x. So this is the first equation that I have. Okay, and then the second identity that they want you to expand, okay, or to prove is cos. Then A plus B. So cos A plus B is, if you expand it, you have cos A cos B minus sin A sin B. So again, if I try to simplify the 3x plus x here, then generally what do I have here is cos 4x, which is equals to cos 3x cos x minus sin 3x sin x. So I will treat this as a second equation. Okay, so I already expand what they asked us to expand now. Okay, what they want you to prove? So prove that your equation, you prove that you can get sin 3x sin x is equals to this part on the left hand side. Okay, so how can I keep sin 3x sin x? So to keep the sin 3x sin x, maybe for me what I need to do now is I need to take equation number 1 minus equation number 2. Okay, so 2x minus 4x, when you write out, it should be cos 2x minus cos 4x equals to cos A cos B minus cos A cos B becomes 0. Sin A sin B minus negative sin A sin B, then you're having 2 sin A sin B. And then when you try to bring everything over, okay, so you have 1 over 2 and then cos 2x minus cos 4x. So this is the equation that they want you to prove. So you get the answer already for proving part. Okay, all right. So after that, if you continue to part number 2, okay, so for part number 2, they are asking you to do the integration for sin 3x sin x. Okay, so again, we never learn how to integrate sin 3x sin x together one, right? We only learn either sin 3x or we only learn how to integrate sin x. But we never learn how to integrate both things together one, right? So to integrate this one, the method is you have to use the result that they want you to prove in the first part. So sin 3x sin x is equals to what? Is equals to this one. So you just substitute the result in part 1 straight away. Okay, so you do the so you do the integration straight away lah. But before I do the integration, I will just try to take out the constant first, which is the half. Okay, so if you look at the equation now, the integration now, you will see that you can integrate cos 2x, you can integrate cos 4x separately. Before it's multiplied, so you cannot integrate them separately, but now it's a minus between them. So you can have two terms here, and you can integrate the terms separately. Okay, so you can start now. How to integrate cos 2x? So integrate cos 2x, you should have sin 2x divided by 2. So how to do the integration in detail, I'm not going to show you here already lah. So please go and have a look for the previous chapter 3, for the previous video. Alright, how to do the basic integration. Okay, then integrate cos 4x, you have sin 4x, and then divided it by 4. And you need to substitute the value of pi over 3 and also pi over 6. Okay, then after that, what you need to do now is you try to substitute everything in. Okay, so again, the steps, when you look at it, substitute everything in, it might look a bit complicated. Okay, so no matter how, you just try it slowly. All right, so half. Okay, so I'm having half, substitute pi over 3 into the equation. Then you're having sine 2 pi over 3. Okay, then minus 1 over 4, substitute pi over 3, you have sine 4 pi over 3. Okay, then again, when you substitute it in, you have negative, substitute the pi over 6 now, then you're having half, and then sine pi over 3. Okay, then minus 1 over 4, substitute pi over 6 also, then you have sine 2 pi over 3. So all the details here, you just need to be very, very careful, okay, because you might make careless mistake very easily. All right, okay, then now, they just want you to show that if you simplify all the things here, you'll get 1 over 8 square root 3. That means your answer should keep everything in the third form. So sine 2 pi over 3, if you use the calculator, you'll get square root 3 over 2. So for those who are using MS calculator, you need to draw the triangle to help you. You also need to know if, let's say, for 2 pi over 3, which is the quadrant and which is the basic angle value that you have to refer to. All this you learned it in AS before. All right, so again, if let's say you already forget, spend some time to recall it again. So this one is the answer that you should get, square root 3 over 2 minus 1 over 4. What is the value for sine 4 pi over 3? Sine 4 pi over 3, you should get negative square root 3 over 2. Okay, then minus again, sine pi over 3 should be square root 3 over 2. Okay, and after that, you can have a plus here. Okay, you can have a plus here, 1 over 4 sine 2 pi over 3. So sine 2 pi over 3, it is also square root 3 over 2. Okay, so if you try to simplify everything here, okay, so I have 1 over 4 square root 3 plus 1 over 8 square root 3 minus 1 over 4 square root 3 plus 1 over 8 square root 3. Okay, so I put everything as a square root 3 in detail as the main object. Then you can see that 1 over 4 square root 3 minus 1 over square root 3 becomes 0. 1 over 8 plus 1 over 8 is 2 over 8. So 2 over 8 divided by 2, and therefore you get 1 over 8 square root 3. And this is how you get an answer that they want you to prove. Okay, so you can see that if, let's say, for this kind of integration, usually for A-level style, they will give you first part, ask you to prove some identity first. Then second part, they will ask you to do the integration. So if you're having this kind of question, right, that means what? That means you have to actually apply the result that you get in the first part into this integration. All right, so the style is usually like this. Okay, so that's why you need a lot of knowledge in the previous chapters one. All right, so like all the value here, how to get the sine 2 pi over 3. So all these are very basic. If you press calculator, of course you can get the answer. But for those who are using MS calculator, so you have to recall back all the triangle, all the basic angle, how to look at the value from the quadrant and so on. Okay, so all the details here I'm not going to teach you again. Okay, here in this video. Right? Okay, so we are having example 8 here. So you can see the pattern now. Right, then let's continue to the next example, example 9. Okay, so for example 9, okay, you'll see that in second part, they ask you to integrate cos power 4 theta. Okay, but for this cos power 4 theta, if you want, you can apply the method that I showed you before, right, in the example 7. But now, if you look at this question, they actually ask you to prove something in the first part. So that means later, when you want to do the integration for cos power 4, it will be better if you can use the result that they ask you to show here. It will be easier. Okay, if let's say you still want to use the method I teach you just now in example 7, then it might be quite long. All right, so it depends on how the question give you the hint. All right, so for this part, I'm going to use the result that they asked us to prove in the first part. So maybe for me, I want to start proving first. Okay, so for the first part, they asked to prove that cos 4 theta plus 4 cos 2 theta equals to cos power 4. Okay, so what can we do now is I'll start from the left hand side because usually I will start with the larger angle. 4 theta and 2 theta are large angle. Theta is a small angle. Alright, so that's why we are going to start now. Okay, so from the left hand side, you're having cos 4 theta plus 4 cos 2 theta. Okay, alright, so I'm using double angle formula again. Okay, so what's the double angle formula that I can use? Again, I will use 2x equals to 2 cos square x minus 1. I'm not going to use the sine square one. 1 minus 2 sine square, I'm not going to use that. I'm not going to use cos square minus sine square also, because in my answer here, I have only everything with cos. So I will focus on the cos equation only. And then after that, I'm having 4 theta. The 2 theta here, 2x here, I will want to change it become 4 theta. If I change it become 4 theta, so that means the x here, I also need to change it. So what is the angle now? It should be 2 theta. Okay, so for this first part, I'm going to write it as 2 cos square 2 theta minus 1. Okay, and after that, I'm having cos 2 theta here. So for cos theta, what is the formula that we have? It should be 2 cos square theta minus 1. So for this part, I'm going to write it become plus 4 and 2 cos square theta minus 1. Okay, so if I continue from here, then you will see that 2 is a 2, and then cos 2 theta, I will want to write become cos 2 theta square minus 1. Okay, then for the purple color part, I will multiply everything together, become 8 cos square theta minus 4. Okay, all right. Then now, please have a look for this one. This is still 2 theta, right? Cos 2 theta. And they want us to prove everything theta only. So that means this part, I still need to apply the double angle formula for another time. Okay, so if I try to rephrase it everything, what do I have now is, I will have 2. Okay, so cos 2 theta, I use the purple color one again. I'm having 2 cos square theta minus 1 square plus 8 cos square theta minus 1 minus 4, we get negative 5. Okay, then if you continue from here again, so this part, the highlighted part is you apply the double angle formula for another part. Okay, so when you're having a minus b square, when you want to expand it, then you are having a square, okay, minus 2ab plus b square. Okay, then copy the ring part, then multiply everything in, so you're having 8 cos power 4 minus 8 cos square plus 2 plus 8 cos square minus 5. Alright, so from here, again, you try to simplify everything. Negative 8 cos square, positive 8 cos square. Alright, so 2 minus 5, you get negative 3. So to simplify it, you will get the answer that they want you to prove, which is 8 cos power 4 theta minus 3. Alright, so this is the result that they want you to prove, correct or not? Okay, alright. Then after that, you will start with the second part that involves the integration. So what they want you to integrate. Okay, I want you to highlight the word exact value in the second part. The word exact also tells you that your answer should be in terms of pi, third form, but you cannot have your answer in decimal place. Alright, so let me start. Okay, so we are having 0 and then pi over 4. They want you to integrate cos power 4 theta. Okay, so to get the cos power 4 theta, I will rewrite it become, okay, I will write it become 1 over 8, then cos 4 theta plus 4 cos 2 theta, then plus 3. Do you know how I get this equation? From the answer here. Okay, because from the answer here, from first part, if you rewrite it, you will have cos 4 theta plus 4 cos 2 theta equals to this. So you just rephrase it. So you just rephrase it and make the cos power 4 as the main object. So cos power 4 theta, it is equals to 1 over 8. Then cos 4 theta plus cos 4 cos 2 theta plus 3. Okay, so the result comes from the part 1. Okay, all right. Then after that, from here, you will try to put in the value. So, okay, 1 over 8 is a constant. I just take it out. integrate cos 4 theta, you have sine 4 theta divided by 4. Okay, then 4 cos 2 theta, integrate, you have sine 2 theta divided by 2. And then plus 3 theta. Then you want to put in the pi over 4 and also 0. Okay, so if you substitute the value correctly and you didn't do any careless mistake, of course, the final answer that you get should be 1 over 4 plus 3 over 22, 3 over 22 pi. Okay, so this part of the integration, I'll just leave it for you to attempt. Try and see whether you can get the answer or not. So from here, you can see already for the discrete example that I show you here, you will see that first part usually is the proving and the second part is the integration. All right, so for this integration part, please make sure that you try it. All right, don't skip. Make sure you try, put in everything in detail because all this involves the small knowledge that we learned previously. So if let's say you skip it for now in the exam, you also won't be able to solve it one. So make sure that from now onwards, you try to understand every single detail that we need for all the example here. All right. Okay. So the last video, the last example for this video. Okay. So for example 10, this is another pattern. So they ask you to express 4 cos theta plus 3 sin theta in this form. And after that, again, they want you to do the integration. Okay. So again, this we also learned it in chapter 3, the last part of the chapter 3 before, how to change A cos theta plus B sin theta into the R cos alpha or S sine alpha form. All right. Okay. So if again forget, then you just go and refer your chapter 3 again. I'm not going to repeat it here. All right. So to get the value for R and also to get the value for alpha, you just need to apply formula. So R is equals to 1. So R is actually equals to 4 square, 4 square plus 3 square. And then you are having square root 25 and you get R which is equals to 5. And to get the alpha, it is actually tangent inverse B over A. So this is tangent inverse and then B over A. All right, so if you press the calculator, the angle, the alpha that you get should be 0.6435. Okay, because they want you to give the alpha in 4 decimal places, so it should be 0.6435. Therefore, if you rewrite it again, 4 cos theta plus 3 sin theta should be equals to 5 cos theta minus alpha. Okay, so this part actually involved the chapter 3 knowledge before. Okay, all right. Then after you successfully found the R and also the alpha, then you can continue with the second part. So again, for the second part, they want you to do the integration. So we can do integration now. Okay, integrate C divided by, okay, so 4 cos theta plus 3 sin theta squared. And then d theta. Okay, so again, some students, they will try to think of other method, whether they can expand it or not, they can do the integration by themselves. Actually, no need to try. You just really apply the result in first part. So here they already tell you that 4 cos theta plus 3 sin theta equals to something like this, right? Okay, so very easily you can just substitute. 15 is a constant, I just take it out. Okay, so for the bottom part, if I substitute, I will have 5 cos theta minus 0.6435, then the whole thing square, right? According to the question. Okay, then now you try to put the 2 into the 5, put the 2 into the cos square. So you will have 50 integrate 1 over 5 square, you get 25. Cos you square, you have cos square, so cos square theta minus 0.6435. Okay, so maybe you'll say, oh, I still don't know how to integrate cos square because I never learned how to integrate cos square. Never mind, try to simplify first. 50 divided by 25, you get a 2. Okay, then now you're having 1 over cos square, right? So 1 over cos square, what do you get? You will get secant. The identity 1 over cos square is secant square, right? Okay, so now can you integrate the secant square? Yes, because the secant square is the basic integration for trigo. So when you want to integrate the secant square, you have tangent and then theta minus 0.6435, then plus c. And this is our answer. Okay, all right. So by showing you a few examples here, I hope you roughly have the idea. Like in part 1, when they ask you to prove something or do something, right, usually you will need to use the result in the second part for integration. All right, so this is only part of the trigo function. We still have many more and we still have other methods to learn. But if let's say they give you part 1 to prove something or to find out something, then usually you will need to use the result in second part for the integration. Okay, so I cannot show you every single patterns of the question here for the proving and also for solving the integration one. So I just select a few out to let you see that we actually apply different identity to prove. We actually apply the different methods to find out the R and alpha, then how to do the integration, followed by the first part. Right. So again, the style of the question for this part is something like this. Okay, first part is proving, second part is integration. So again, you have to practice a lot so that you know how to apply all the knowledge from the previous chapter so that you can continue and get the answer in this kind of question. All right, so I will stop here for this video where we already cover the more types of the trigo integration. All right. Okay, so in the next video, we are going back into another basic type of integration. All right, then after that, we have some new techniques to learn for the integration. All right, so I will stop here for this video first.